we will discuss wave nature of electromagnetic radiation. The theory which tells us about the wave nature of electromagnetic radiation is known as electromagnetic wave theory. This theory was put forward by J. Maxwell in 1864 or 1870. The main pointers of the theory are main pointers. Number one, energy is emitted. Energy is emitted by a source continuously in the form of radiations or waves. The source may be a heated metal rod or filament of a bulb when electricity is passed through it, and sun. The second point, these radiations or waves, these are associated with electric field component and magnetic field component. This electric field component and the magnetic field component, they oscillate perpendicular to each other. इस फिगर में दिखाया गया है कि रेड से हम दिखाते हैं मैग्नेटिक फील्ड कंपोनेंट, ब्लैक से दिखाते हैं इलेक्ट्रिक फील्ड कंपोनेंट. These two components oscillate perpendicular to each other, and both are perpendicular to the direction of propagation of the wave. On this basis, these radiations or waves are called electromagnetic radiations or electromagnetic waves. The third point of the theory, it has been observed that these electromagnetic radiations or electromagnetic waves, they travel with the speed of light 3 into 10 raised to power 8 meter per second. The fourth point, these electromagnetic radiations do not require any material medium to travel. They don't require material medium to travel. They can travel in vacuum. For example, the light emitted by the sun, the light waves, these light radiations, they travel in space, that in vacuum. So in short, we can say that these waves do not require any material medium to travel. We have different types of electromagnetic radiations which differ only in wavelength, therefore in frequency. So these waves have three important characteristics. Number one, wavelength. Number two, frequency. Number third, that is velocity. These are three important characteristics of these waves. What is wavelength? Wavelength is the distance between two consecutive crusts or troughs. Like this. This crust wavelength है. This wavelength is actually a length of the wave. It is denoted by a Greek letter called lambda. Its units are angstrom, that is 10 raised to power minus 10 meter or 10 raised to power minus 8 centimeter, or nanometer, that is 10 raised to power minus 9 meter, or picometer. PM, we measure these are the units of this wavelength. It's the length we can measure this. These are the units. PM, picometer, 10 raised to power minus 12 meter. So number second is frequency. What is frequency? Frequency is the number of waves passing through a particular point in 1 second. This is denoted by nu, like this. इसको पढ़ते हैं हम न्यू पढ़ते हैं इसको, जस्ट लाइक वी, उल्टा वी है ये, थोड़ा उल्टा इसको हम पढ़ते हैं न्यू, ये फ्रीक्वेंसी कहते हैं डिनोट. सो द यूनिट ऑफ फ्रीक्वेंसी इज, इसका यूनिट जो है दैट इज हर्ट्ज, इसका यूनिट है हर्ट्ज, हर्ट्ज, HZ. What is HZ? 1 hertz is equal to 1 cycle per second, 1 cycle per second. अब इसका बड़ा यूनिट है दैट इज किलो हर्ट्ज, दैट इज 10 raised to power 3 hertz. This is kilo hertz. And one more is velocity. So velocity is the linear distance traveled by a wave. Linear distance traveled by wave per unit time, that is velocity. It is denoted by c. इसको हम cc करते हैं denote. This velocity. These three are related. ये आपस में related है. The relation between these three is c is equal to nu lambda. This is the relation between these three characteristics of the wavelength, frequency, and velocity. C is equal to n lambda. There are two more characteristics. Number, that is, one is called amplitude. Amplitude. This is the height of the, if you have a wave like this is the height of the crust or depth of a trough. इसको हम डिनोट करते हैं, ये height of the, ये भी actually it is measured in, it has units of length. ये length actually है, height of the crust or depth of a trough, it is denoted by A. इसको हम A से करते हैं denote. So its units are same as that of length. This amplitude. So there is one more, that is wave number. Wave number. Wave number is actually number of waves per centimeter. Number of waves per centimeter. Number of waves per centimeter is known as wave number. It is actually denoted by nu bar. Nu bar से करते हैं इसको, ये nu, इसको ऊपर डालते हैं एक लाइन जैसी छोटी लाइन, इसको हम पढ़ते हैं बार. ये nu bar ये होता है बराबर 1 divided by lambda. ये reverse of this wavelength है. So its units are centimeter inverse. इसका यूनिट है centimeter inverse. So this is wave number. Number of waves per centimeter. So these are the characteristics of these electromagnetic radiations or electromagnetic waves. Hope you have got it.